Because the coefficients for a Fourier series involve integrals of f of x in some way, we can use a known Fourier series to kind of work backwards to answer questions that involve integrals of f of x. In particular, suppose that I know a function f of x has this particular Fourier series written here, but I don't know what f of x is. I can still find things like the following. So first of all, if we're asked to find 1 over 2 pi, the integral from minus pi to pi of f of x, what you should observe there is that that's exactly the formula that we have for a sub 0 in the Fourier series. And a sub 0 is the additive constant. So if I look at my Fourier series, I notice that that is pi over 4. So without even knowing what f of x is, I'm able to evaluate this integral because I know that the coefficients are related to integrals of f of x. If instead we were asked for the integral from minus pi to pi of f of x sine of 5x. What I would note here is that this looks like b, first of all, a b coefficient because of sine, and in particular b5 because of the 5x. Now, it's not exactly equal to b5 because b5 should have a 1 over pi out front. So if, just to be clear, if b5 is equal to 1 over pi, the integral from minus pi to pi of f of x sine 5x, notice that this means that pi times b5 would be just the integral without the multiplier. So that's what I have to think about here. This looks like b5, but it's missing the 1 over pi, so it must be b5 scaled by pi. So this is pi times b5. And then what I need to do is look at my coefficients in the Fourier series to determine what b5 is. So here, I'm going to notice that this is the formula for bk. And here we get sine of 5x. So b5 should be the coefficient of sine of 5x. And that occurs when I just plug in k equals 5. So we get negative 1 to the 5th over 5. So we get negative pi over 5. We can also do a similar thing with this one here. This looks like instead a sub 5 because it's cosine instead of sine. It's also missing the 1 over pi, so I can see that this is now pi times a sub 5. But I will say this one's a little bit more complicated because notice what's happening here. This is an example like we've seen where every other coefficient is 0. And in particular, we get from this formula that the coefficient, for instance, of cosine 2x is, sorry, there should be an x here, is 0. The coefficient of cosine 4x is 0. And that's why we have these 2k minus 1s in there. So if I'm looking for a sub 5, it matters that what I really need to focus on is finding the coefficient of cosine of 5x in our formula. So what we're really considering is I don't plug in 5. So that's the temptation here, I'll point out. If we were to plug in 5 for k, what we'd really get is cosine of 9x, and we'd actually then be looking at the coefficient being a sub 9. So what I'm thinking of here is, when does 2k minus 1 equal 5? Well, that's when 2k is equal to 6, and so it actually happens when k is 3. So we're really plugging in 3 for k to get the coefficient. So this part is representing the coefficient, but rather than plugging in 5, we're going to plug in 3. And of course, as we already know, 2k minus 1, when k is 3, that becomes 5. So what we get out of this is that we get pi times negative 2 over 5 squared, and then pi is in the denominator. So here, those pi's cancel, and we actually get negative 25. And then finally, kind of building off of that, suppose we were asked for instead the integral of f times cosine of 6x. If I were to do a similar computation to what we did here when we were trying to figure out how to make 2k minus 1 equal 5, well, if I try to make 2k minus 1 equals 6, then we get k equals 7 halves. And keep in mind, k can't be a fraction here. K has to be an integer value because it's the summation index. So if you encounter something like this, where that's not really possible, what's happening here is that that means that the coefficient is actually 0. And again, that makes sense when we think about the formula here. So we're skipping over even k values, because what that means is the coefficient of those even k values was 0. Consequently, if the coefficient is 0, then the integral would have to be 0 as well. So think about this as similar to when we know a Taylor series, we're often then able to look at the coefficients of the Taylor series to give us information about derivatives of our function. And instead here we see that if I know the Fourier series, we're able to look at coefficients to give us information about the integrals, certain integrals that involve f of x.